It's Dr. Marty back again. We talked in our last two videos, 5.3, we talked about slope-intercept form, which is y equals mx plus b. And in our last video, 5.4, we talked about point-slope form, which is y minus y1 equals m times the quantity x minus x1. Today, we're going to talk about our final form of equations for a line or linear function, and that is standard form. Okay? Now, standard form follows the formula ax plus by equals c. Ax plus by equals c, where a, b, and c are all real numbers. So here's an example. 5x plus 3y equals 15. Okay? Now, standard form is generally used when we either have the x and y intercepts or we want to find the x and y intercepts. And let's show you why, okay? Because in standard form, ax plus by equals c, the x-coordinate of the point where a graph crosses the x-axis is easily found by just setting y equal to 0, okay? So x-intercept, where it crosses the x-axis, if we set y equal to 0, we get 5x equals, here we would get 5x equals 15. We could divide by 5, x would equal 3, okay? So that's the x-intercept. Here's an example, 5, 0, okay? In this case, it would be 3, 0, all right? The y-intercept is the y-coordinate of the point where a graph crosses the y-axis, This is when x equals 0, okay? So up here, if we set x equal to 0, we'd have 3y equals 15. We would get 0, 5, right? Divide by 3. So that'd be another example, 0, 5. Here's an example, 0, -3. Let's go ahead and play with this and see what it actually means. It's a little bit hard to tell when you're just talking about it. Let's do some problems and actually try to figure it out, okay? So here we have equations written in standard form, and we're going to try to find the x and y intercepts. To do that, we're going to set x equal to 0 and solve for y to find the y-intercept. Set y equal to 0, solve for x to find the x-intercept. Okay, let's start with the x-intercept. We have 4x plus 2y equals 0. All right, we're going to set y equal to 0. So now we have 4x plus 2 times 0 equals 12. 4x plus 0 equals 12. 4x equals 12, divide by 4. We get x equals 3. X equals 3. So our x-intercept is 3, 0. We're going to do the same thing down here, but this time we're going to set x equal to 0. 4 times 0 plus 2y equals 12. That means 0 plus 2y equals 12, or 2y equals 12, right? Because the 0 gets gone. Divide by 2 on both sides. Y equals 6. So 0, 6 is our y-intercept. See how easy that was? That is what I was trying to explain. That's why standard form is helpful. Because when you have it in this form, 4ax plus by equals c, it's very easy to set either x equals 0 to find the y-intercept or y equals 0 to find the x-intercept. Let's play around with that over here. 3x minus 6y equals 18. Okay? Find the x-intercept, we're going to set y equal to 0. So 3x minus 6 times 0 equals 18. I'm going to skip the step of writing this out because I know this is going to be 0. So I get 3x equals 18. Divide by 3. Divide by 3. X equals 6. Okay? So we've got 6, 0. It's our x-intercept. Here we're going to set x equal to 0. 3 times 0 minus 6y equals 18. Negative 6y equals 18. Divide by negative 6. Divide by negative 6. Y equals -3. So we got 0, -3. Okay? So the x-intercept, point where the graph crosses the x-axis. Y-intercept, point where it crosses the y-axis. Easy to find in standard form, ax plus by equals c, by either setting x or y equal to 0 and solving. Okay? Now let's talk about graphing using these intercepts. Okay, we're going to do this kind of the inverse. Here we're going to graph using the intercepts. Now this one, they're giving you the intercepts. X-intercept is 4, y-intercept is -3. Well, that's about as easy as it gets. As easy as it gets. So if the x-intercept is 4, that means we're having a point at 4, 0. We're going to go 1, 2, 3, 4, and put a point. Okay? If the y-intercept is -3, that means we're going to point out 0, -3. We're going to go down 1, 2, 3, put a point. All we got to do is draw a line like that connects those. Now this one's going to be a little bit trickier. This says given an equation 2x minus y equals 6, find the x and y intercepts, and then we're going to have to graph. Okay, so the first thing we have to do, find the x and y intercepts. Okay, so to find the x-intercept, we're going to set y equal to 0. Okay, so we have 2x minus 0 equals 6. 2x equals 6 divided by 2. X equals 3. So 3 comma 0 is our point. We can go ahead and graph that. 1, 2, 3, put our point there. To find the y-intercept, guess what? We're going to set x equal to 0. 2 times 0 minus y equals 6. Minus y equals 6. Divide by negative 1, get rid of that. And y equals negative 6. So at 0 comma negative 6, we've got that. So 0, 1, 2, 3, 4, 6. And we have a line. Okay? So it's that simple. That's how you're using standard form, or using x and y intercepts to graph in this case. This was a standard form equation where we found the x and y intercepts. Remember, it's easy. Here we are actually given them. Finally, let's learn how to convert to standard form. Okay, convert to standard form. And at first I'm going to introduce something that I didn't talk about before. And that is, in standard form where we have ax plus by equals c, the a is always positive. Okay? A is always positive. A is always positive. Okay? So if we want to convert from, say, slope-intercept form to standard form, we've got to follow the following steps. First, we've got to get rid of any fractions by multiplying the entire equation by the denominator. Second, we've got to use a distributive property if it's necessary. Third, we've got to move x and y to the same side. Same side. Remember, it's ax plus by all on one side equals a constant. Then, if a is negative, you have to divide everything by negative 1 to get a positive. So let's try this one. We've got y equals 3x plus 4. Okay? Well, this one's going to be pretty easy. Right? We want to get x and y on the same side. So what I see is if I subtract 3x here and 3x here, I've got negative 3x plus y equals 4. So this is in the form ax plus by equals c, but there's a problem. Okay? It says if a is negative, then you have to divide everything by negative 1. And here, our a, our coefficient of the x term, is negative. So we're going to divide this by negative 1, this by negative 1, and this by negative 1. And we get 3x minus y equals negative 4. Now that is an equation in standard form, because now we have a positive a, and we have x and y on the same side. Right? Let's look at the next one. Sorry about the phone call. Here we've got y equals 2/5 x plus 3. So step 1 was to get rid of any fractions by multiplying the entire equation by the denominator. So the denominator here is 5. We've got 2 over 5. Okay? So we're going to multiply by 5 over here, 5 over here, and we get 5y on this side equals, now 2/5 times 5, I guess I can distribute this. Let's distribute it to make sure you can see it. So I'm going to have 5 times 2/5 x plus 5 times 3. So I get 5y equals, these 5's cancel, 2x plus 15. Okay? Now we need to get, we've gotten rid of the fractions. Do we have to use the distributive property? No. Move x and y to the same side. Minus 2x, negative 2x plus 5y equals 15. Now, some of you might have written this as 5y minus 2x, and that's still the same thing. The reason I've put the x first is because our form is ax plus by equals c, and so I want to keep it consistent. Now we have a negative number, so we have to divide everything by negative 1. We get 2x minus 5y equals negative 15. So that's standard form. Standard form, very helpful if we want to use x and y intercepts or find x and y intercepts. It can be really easy to graph by using the x and y intercepts. And so converting to it, we just want to make sure that when we get it into ax plus by, so both the y and the x values are on the same side, if a is negative, we divide everything by a -1.